Hey class, this week's lab is the Golgi tendon organ or GTO lab. And all that is, it's just a tension receptor located inside of a skeletal muscle. So more or less what it does, it senses the amount of tension on a muscle, it sends a message back to the nervous system, and then that message in the nervous system stops a message to contract. So more or less what it does, it senses if you're lifting something that's excessively heavy and it stops you from lifting it. It actually makes you relax instead. So what that is called is a relaxation reflex, or it's also called autogenic inhibition. More or less just the muscle inhibiting itself from contracting hard to protect yourself from injury. Now, whenever you start a strength training program, what actually happens at the beginning of it, if you look at this graph right here, we gain strength, but we aren't necessarily gaining muscle mass or having muscle hypertrophy right at the beginning of it. So most of what's happening, our nervous system is actually changing so that we can lift more weight. And one of the things that seems like it's happening is the Golgi tendon organ is actually becoming desensitized to whatever loads are being placed on it. Now, that happens in a more long-term sense. So if you're lifting weights for weeks and months and so on, that does seem to happen. But we can seem to turn down the Golgi tendon organ acutely. And that's actually the goal of our lab today. So if we can make the Golgi tendon organ be less sensitive to tension for a short period of time, we can produce more force. And how we're going to test it, actually more power. So what we're going to do, three individuals in your group are actually going to be tested today. One person is going to do some heavy squats, another person is going to do a depth jump, and another person is going to stretch their hip flexor. So how we're going to test the power, we're actually going to have you do just a simple jump, hands on your hips, bend down about 45, 90-degree angle, something like that, jump up, and we'll record like with one of our phones. Like I will use mine in lab if you can't use yours. We'll record it, slow it down, see how many inches they're actually able to jump up. And then we'll go through and do those three different things, the heavy squats, the depth jump, or the hip flexor stretch. And then after we're done with that, jump again. So what a depth jump is, right here, you start on a box, you jump down, and then you jump up. We'll just have whoever's doing that do 5 of those. For a back squat, 3 to 5 repetitions of something pretty heavy, like 80, 85, 90%. Like if you're crazy strong, or like if you have the capacity to do it, 95% of your one repetition max. I don't recommend that though. Like somewhere between like 80 and 85 would likely work the best. So do that. Other thing that we could do is this hip flexor stretch. Now, granted, this one, I'm just doing this for purposes of increasing the vertical jump because this actually isn't manipulating the Golgi tendon organ. What's going on here, the hip flexor, that's actually an antagonist to the hip extensors, which the hip extensors being like your gluteus maximus. That is one of the, prime movers in a vertical jump. So the antagonistic muscles, whenever they're contracting, actually inhibit the like agonist muscles from contracting as hard as they possibly can. So if we stretch this out for here, I'm having us do it for 2 minutes. It seems like that could deaden um, the hip flexors, like reduce the force output from the hip flexors so that we can have a more full contraction in the hip extensors. So what we're gonna have to do, we're gonna have to like make a table from Excel. I'm about to hop over to that, and you'll make a line graph with a jump in centimeters on the y-axis and trial on the x-axis. You're gonna have to tell me what was the percent increase in vertical jump with all of these three different people. And then I'm going to ask, like, which intervention had the largest impact on vertical jump and how could we use this for training individuals for power? So let's go ahead over here and start setting up an Excel file. So what I'm going to want, depth jumper. So semicolon right there. So right there would be the person's name. Let's say my dog Lily's doing it. Next, weight. Good, excellent. An LBS. Okay, let's say that she weighs, I don't know, 145 pounds. Next thing, weight in kilograms. Hopefully everyone remembers this equation, so click on that, press equal sign, click on the weight in pounds, and then divide it by 2.2046. Enter that there. Good. Next thing, we're going to need a pre-jump height in inches. So double click there just so that extends. We're going to extend this down, and instead of pre, let's put post. Ooh. Post jump height. Extend that a little bit. So let's say that her first jump was 12 inches, second jump was 14 inches. So if we want to convert that to centimeters, I'm just copy and pasting it over here so that it's a little bit easier for me to change it. Say I want this in centimeters. Centimeters. And remember, pause the video anytime you need to if I'm going too fast for you. So equal sign. That multiplied by 2.54. And then I can extend that down. Good. There we go. Now there's actually going to be another calculation that I want you to put into this. Peak anaerobic power. Watts. So we can just bring that down right there. And there's this equation. You don't need to have this equation in your Excel file. Just follow along with how I am putting it in here. So equal sign, close parentheses, 60.7, so 60.7 right there, multiplied by jump height in centimeters, so that's that. So I close the parentheses, and then I add plus, open parentheses, 45.3 multiplied by body mass in kilograms, and then close it. And then subtract 2055. This is just a relatively easy equation to figure out what someone's peak power in watts is, like from their vertical jump. So if you drag that down, that like 2,700, that makes sense. 100 doesn't make sense. So if we check on that equation, we're actually measuring nothing for their weight in kilograms. So just move that up. Good. Okay, good. 2,700 to 3,000 right there. Great stuff. Next thing, let's do squat. put the name, let's say my dog Daisy is squatting. Here, we could actually just copy and paste all of that right there. Now, delete those. And those equations should actually still stay. So make sure you're following along with this LDS. And then, gosh, if I knew how to type, huh? Equals that divided by 2.2046. Good. So let's say Daisy weighs 155 pounds. And let's say that she jumps 15 inches and 16 inches. Good. So Daisy actually is a little bit more fit than Lily, so that makes sense to me. The very last thing, the stretcher. So name, one of my old dog's names was Roscoe, so I'll put him in here. You could just copy and paste this right there. Change the weight, and you can copy and paste all of those equations right into here if you make sure that you're skipping the certain columns, or certain rows, I'm sorry. So if I alter these, and say Roscoe weighs 165 pounds, because Roscoe was an actual full-size dog, so he was bigger than Daisy and Lily, 20 inches and 22 inches. So if you look at all of this right here, right there, right there, those are all of the places, oh, and that one, where you can actually, where you're actually supposed to have open for our lab in class, where you can actually like alter the numbers being in there. The rest of these are equations, and it would be best if you just left them. Okay, so there's that. Now, next thing, we need to, let's go back and look at this. So insert the table from Excel. So how you would do that, just copy all of this, Control or Command C, bring it back to right here, just paste it in right there. That's how that works. Next, insert a line graph of the 3 participants. I'm sorry, I was typing too fast. Jump height in centimeters on the y-axis, trial on the x-axis. So what we need to do, line graph. Let's go on to over here. So centimeters, centimeters, and centimeters. This one is actually a little bit complicated, so try to follow me as best you can. Highlight that, highlight those two, click on Insert. Go to over here, line graph. Okay, good, got that. Vertical jump, that'd be kind of cool. All right, let's go and add our chart elements to it. Horizontal, vertical. Okay, so let's go back and look at exactly, okay, jump height, and then trial. So jump height, in parentheses, cm, over here, trial. Okay. Now that's only one of them. We're going to have to do two more. So I want you to click on this, click on Select Data. So this first one, series, let's edit it. Okay, so the name right here, series name, then needs to be depth jumper. All right, I need to add another one. So series name, squatter. And then series values, click on this, and then you're going to highlight those. Press enter. Press OK. Good. There we go with that. And notice right here, we have two lines. So we need to add the third one, the stretcher. So add stretcher. And then with this, highlight these two in centimeters. Press enter, and then press OK. Press OK, and OK. There we go. You'll need one more thing on this, add chart element, where it says legend. How about right there? So now I know depth jumper, squatter, stretcher. Figured out all of those. Control or Command C, then right here, paste that in there. Good stuff. Next, two things that you're going to have to do in lab, figure out what percent increase from trial 1 to trial 2, the depth jump, squat, and hip flex stretch was, and then answer these questions and go on. That's really going to be the totality of this lab. It should go relatively quick. Excellent. See you all in class.